Today we are going to review solving multi-step equations. Most of you guys are already really good at this, so we're just going to do a quick recap and go over some questions I normally get from you guys. We are going to start off with our first equation. We have x plus 4 minus 3x equals a negative 10. So when we have an equation like this, first thing we want to do is look at one half of the equation at a time. So I'm going to draw a line right through that equal sign. I'm going to look at my left side first. If I look at the left side, right away I see I have two like terms. I have this x and the minus 3x, so I'm going to combine those two. I get a negative 2x, and then I'm going to bring down everything else. So I have the plus 4, and then equals a negative 10. So from here, remember our goal is to isolate the variable. So I'm isolating the x, or getting the x all by itself. So to do that, I'm going to have to move the 4 to the other side using inverse or opposite operations. So my 4's cancel. I'm left with negative 2x equals a negative 14. Last thing, just divide by that negative 2. So we get a positive 7 for our first answer. So that's kind of your quick recap. Make sure you're combining any like terms before you start moving things to the other side of the equal sign. So number 2, this is one I really wanted to go over with you guys because this is one we had issues with in the past. So when we have an equation like this, x over 4 minus 1 equals 2, the very last thing we get rid of is the number with the variable. If we look at the last equation, right here, that 2 was the last thing that I got rid of. So over here in this equation, the 4 is going to be the last thing that I get rid of. So first thing I'm going to have to move then, instead of the 4, I'm going to have to move that 1. So ignore that 4 for now, move everything else. So we have x over 4 equals 3. Now I have to get rid of that 4, now that that x over 4 is all by itself. So to get rid of it, I want to do the opposite. I know that this division sign, that fraction bar means division. So I'm going to do the opposite. I'm going to multiply 4 on each side. By multiplying 4 on the left, they cancel each other out, and I'm left with just a plain x. On the other side, I multiply those two together to get my final answer of x equals 12. So let's look at just a couple more. So my third example for you guys, I have a distributive property. 8p plus 8. So as soon as you see parentheses, as soon as an equation has parentheses, you want to take care of those first. And you guys already know, when I see parentheses, I use the distributive property. Just be careful here. Make sure you're distributing a negative 5, not just a 5. So I have a negative 40p minus 40. And then from here, it's just like a regular two-step equation. I want to move the number with no letter with it. So that's this 40. I'm going to add it to the other side. Remember, I'm always doing opposite operations. So I end up with 200 equals negative 40p. And then I can divide both sides by that negative 40. And I end up with my final answer of negative 5. So I have 2 more examples for you guys. So example 4, we have 10 minus 2k equals k plus 5 minus 3k. So I don't see any parentheses, so we're not distributing. So instead, all I have to do is combine my like terms. So look at one half of your equal sign at a time. So on my left side, there's no like terms. On my right side, I have the 2 k terms to combine. So I'm going to combine my like terms. I'm just going to bring down those 2 things on the left side. On the right, I combine k minus 3k and get a negative 2k. So from here, you have some different options. You can move whatever term you want. I like to move all the variables first. So what I'm going to do is pick up this k right here and I'm going to add it to the other side. And that cancels it from here. So now if I bring down what's left, I have 10 negative 2k plus 2k. That actually equals 0. So this gets canceled out too. And then the only thing I'm left with is a 5. So this answer should look really weird to you guys. Whenever the variables cancel out in your final answer, this is what we call one of the special cases. So does 10 equal 5? No, it does not. So because 10 does not equal 5, that means no matter what number you plug in for k, you will always have no solution. So no matter what number you plug in, it will never ever be a solution. So this is one of our 2 special cases, no solution. So if we look at one last example, you guys can probably guess it is going to be another special case. So we have x minus 7 equals negative 11 plus x minus 4 plus 8. So this looks a little bit longer, more complicated. All I have to do is combine my like terms still. So look at 1/2 at a time. My left side, nothing can combine. On my right side, I have the 8 minus 4 and negative 11. All of those can be combined. And when I add all of those up, I get a minus 7. So from here, I'm going to want to move all my x's to one side. Again, if you choose to move one of the negative 7s, that is fine. So my negative x's cancel right here. On my other side, they also cancel. And I am left with negative 7 equals negative 7. So again, I see all my variables got canceled. And this is my final answer. So this one is saying no matter what number you plug in for x, it will always be a solution. So this is our infinitely, let's write that out nicely, infinitely many solutions. Okay, so that's what our 2 special cases look like. So just remember, it's a special case if the variables cancel. Sorry guys, my writing here is getting a little sloppy. So if the variables cancel, you will have a special case. And then what I'm adding here is if you get a false statement. So like in our previous example where we had 10 equals 5, that's a false statement. If you have a false statement, then it is a no solution. If your variables cancel out and you have a true solution or true statement, that is the case that we just covered, which is infinitely many solutions. So those are the main problems I wanted to go over, especially those special cases, because we haven't talked about those in quite some time. So this is your quick review of solving multi-step equations.